Luis is going to talk about a decision support tool for land use conservation planning. And with this, I welcome Luis, and please start.
Thank you, Nadine, and thank you everybody for listening to this talk in this new era of remote webinars, and we all are getting used to this kind of technologies nowadays. And thank you to Mark News for extending the invitation to me and giving me the opportunity for sharing some experiences that we have developed in Mexico and in our institution on basically what you could say regional integrated planning. That let me say, I cannot switch my, okay. Just to get our bearings right of what I'm going to talk about, actually Hallie sent me this one document, PDF comment some time ago on some planning tools that or instruments that the government in this province has available, has to implement. That they call it spatial development framework. So I'm going to talk about that around these exactly the same issues, the same problems. And basically, it's very similar what you have over here and the kind of questions that this framework for South Africa, I guess, is required. But this is, as you know, it's a very challenging task, because what we're talking is on different aspects of the same problem. But we have to deal with complex system dynamics, issues of governance, multi-sectoral demands, and different sources of uncertainty. And all of this has recently been framed under the label of decision-making on the deep uncertainty. Basically, this deep uncertainty refers to a position where you cannot reduce the uncertainty. You acknowledge that uncertainty cannot be eliminated from decision-making. So instead of trying to eliminate it, what you do is to use massive computational experiments to model every aspect that you can imagine of, and from that you would expect to learn something about the system, the complex socio-ecological system you're dealing with, and perhaps you can determine which vulnerabilities you have to deal with, and from that to decide or to avoid bad decisions. It's a general framework. So we have worked under this framework in our work, and of course this is very challenging. We're dealing with wicked problems, with socio-environmental systems that even trying to describe them is terribly difficult, and our approach is hopefully transdisciplinary. We have complexity in the social, environmental, political, you name it, issues. And of course, I already talk about uncertainty, which I misspelled it there by accident. So, of course, this is very problematic. We don't know how to begin and how to end. Another thing we have to acknowledge is consensus building is difficult, very difficult. Consensus we should aim to try everybody to row in the same direction, but that this cartoon shows that is more easily said than done. Consensus building is a a difficult process, basically because everybody has a different frame of reference. So we have different viewpoints, values, needs, information, and capacities that we have to acknowledge beforehand in trying to develop and land use planning scheme. And on the other hand, we have the limitations of our tools. So sometimes the tools are very specific and give you partial responses for the whole system, like this cartoon at the right illustrates. On the other hand, the tools we're trying to implement are just useless because they don't deal with the right scale with right framework. So we have to have access to the proper tools to do it. And now we face in our recent work in these recent years with the issue of participatory planning after COVID. It was during the pandemic, and this is an actual case. So we have to develop techniques and procedures to have participation online. And this is to contrast we have to have hybrid meetings with in presence with a very few people that could come to the meetings, and the vast majority was in this case in participating using Zoom. So that all the techniques we had for facilitating participatory planning had to be modified in this new reality. And after Mexico opened up and we had the opportunity to invite people to actual meetings, of course, nobody wanted to come because it was more comfortable to connect through Zoom. So this is a new reality. So we start still trying to measure the difference of the quality of participation, non-participation between presence, participatory meetings and workshops, and participatory online. We still have troubles how to measure it. But the tools I'm going to present were fundamental for carrying out online participatory meetings that otherwise would have been impossible. So the problem with all these complexities and challenges, the question is, how does it end? Because when you start studying or trying to implement this kind of transdisciplinary work, is the feeling is that you're falling down from a tall building and everybody is watching, but nobody is helping you. So the question is, how does it end all this process? So the equivalence of the spatial framework for planning that you have in South Africa, in Mexico, it's called ecological ordinance. And basically, it's equivalent. This ecological ordinance is required by law and has to be implemented. And this is just where it comes from, and I assume that that's the case for South Africa as well. It's come from the Rio Convention of 1992 with Principle 10 on the World Summit in those years, but also it comes from the meeting in Johannesburg in 2002. So basically, what we're saying is what you have to identify the unit pattern that optimize land suitability. We have you want to optimize the use of the land, but under two restrictions, that you minimize conflict between different sectors and maximize consensus. So what you're talking about is to develop a multi-objective decision-making model that satisfies all the stakeholders simultaneously. And I'm going to talk a little bit. Unfortunately, I don't have access right now to because of the distance and the time difference with Mexico. an online computer platform that we have developed in Mexico for carrying out this the ecological ordinance process. So basically, this process has four steps. From the characterization, but basically is developing your databases. You have a diagnosis, and then a prognosis, and then a proposal. This linear stepwise process, actually, as you already know, if you have worked with this process, it's just a way of discretizing a continuous process where you have to go back and forth several steps and several times along a very difficult process. All this work takes about 2 years to finish from start to end. And I would say that the most challenging aspect is not the computational aspects or the methodological aspects of the problem, but the social process of building trust and confidence along each one of the steps. So basically, the first step in the diagnosis, what we call diagnosis, is to carry out what is called in the literature like land suitability or suitability analysis in general, which basically is to develop a multi-criteria decision-making model that is attached to a geographic information system. And what you have in that equation is one of the most used method for land suitability, was a weighted linear combination with restrictions. That's very well known. So when we started, I started teaching all these methods in my university. The process of carrying out this actually is very challenging, but because there are many steps. You have to develop a geographic database, but also you have to train the people on how to obtain the weights with that W, the weights of the different attributes of the land through multi-criteria model, and then how you develop value functions to capture the heterogeneity of the territory, and then how you identify the restrictions. And also you have to teach how to facilitate a meeting and how to integrate everything. So there are too many things all together. So I found it impossible, and I was very frustrated when I wanted to train people, and because there are too many abilities and skills that you have to handle at the same time. For example, this is an actual process that you carry out for marine spatial planning in the Pacific Ocean of Mexico. And you have the process you have with at the very top, you develop your characterization, that means your databases, and then you develop your GIS MCDA approach. What you have on the left side, you have an illustration of a multi-criteria model that we typically use the analytic hierarchy process or the analytic network process. Either one works very well. There are techniques. And what you have on the right, we develop value functions that capture the heterogeneity of the land. A value function is only a mathematical expression that normalizes your attributes. For example, yeah, you have in the line on the right, you have a slope. On the abscissa, you have the true scale, the natural scale of slope in degrees, and then you transform it in degrees of desirability from the best state or ideal state to the anti-ideal or worst state for an activity for carrying out that activity on the territory. So you develop that in working with in participatory workshops. But then you have to start reviewing it and validating the model with your stakeholders, with the people that participate. So at every step, you have to review it and correct whatever whatever concern, issue, interest your model has not captured well. And then you aggregate all this information that in this case, this is basically that numerical classification, analogous what you do with satellite imagery. What you have, for example, in this case, 23 sectors, different sectors, each sectors carrying different activities in the ocean. In this case, this was a marine planning. And then you identify homogeneous, what we call environmental management units, that are identified in terms, not in their natural scales for each attribute, but in terms of the desirability for the different sectors. This is another example. This is now a land suitability analysis. This was for a state in Mexico, which is Yucatan, in the peninsula of Yucatan. And in this case, we have 16 sectors, and each of these sectors has a different suitability map, as you may see then. Well, the way we develop this map is with the actual tool. We use this our computer platform. That we have the value function that you have in this case. For example, this is a logistic inverted logistic function that transform the natural scale for, as I said, to a desirability scale from 0 to 1. And the way we apply this technique is we ask, we first train the participants in our workshops, and I said it was on distance in Zoom and online. And then after we train, then we start question and modifying this the parameters of this curve, and and also actually seeing the different how these different parameters modify what you're looking at. In this case, the redder or the darker is the best condition, and the yellow is the worst condition. So you can change colors, frames, whatever. So you help the participants to understand what's going on territorially when you modify one of these parameters, and you verify that you are capturing the desirability of the territory for the needs of each stakeholder. This is another example of same thing. So after that, you get well, sorry. In this case, is now that we aggregate all the different suitability attributes and develop a suitability map for a certain activity. For example, what you're looking at is after you aggregate all the different map layers for the different land attributes, the geometric criteria model is transferred to the GIS. It's basically that. What you're identifying here is an activity that is highly dependent on the roads and highways, but it's not. It has to be away from highways, from major cities. So you repeat all this process until the people is satisfied, the stakeholders. And this is another example of suitability analysis from the same area. This is a final product after you aggregate all the values for an individual activity. And in this case, you transform it now the colors in a scale where red is the worst and dark green is the best track of land for a specific activity. The next steps in our process, when you finish we repeat this process, for example, with 16 sectors in the case of this state of Yucatan, or the 23 sectors when we develop the marine spatial planning. The next step is to analyze the conflicts between groups. So in here we have two sectors with different suitability maps, of course, One is agriculture, it's basically industrial agriculture, and the other one is an important activity for the communities in the state, which is bee honey production actually with the European bees and also with an endemic bee and for Central America. And what you see when you overlay these two maps, you can develop a map of conflicts if you see the table that is below, you can see you can depict the areas that have a very high suitability for both activities simultaneously. The problem with agriculture and apiculture is that the beekeepers could not export their product to Europe because of the risk of transgenic agricultural products, basically soy and in some regions. So in this way, you can depict how the conflicts is actually occurring in space. And again, when you develop all these conflicts, all these suitability maps for all the activities, then you develop a zoning maps, which is of these polygons that you, with a number, is an individual environmental management unit. And basically, what you carry out here is a procedure, which is a resource location allocation algorithm that identifies which activities should you put in place in a way that you maximize land suitability, but avoid conflict. And with that information, you may start working in crafting regulations for avoiding for promoting the best uses of the land and avoiding the conflict or mitigating the conflicts if that is possible between incompatible sectoral activities. The next thing is, but this is a static picture of the land. The next step is to project what could be how this conflict could evolve into the future. So it's in this case when we start using the philosophy of the MDU, decision making on the deep uncertainty, and we carry out massive computational experiments just to detect the thresholds of how an activity would affect another one. So we develop a system model that it's with all the connections, and this was developed in collaboration with the representative of the stakeholders. And as you may expect, what you end up is with a big mess when you develop a model that is in collaboration with everybody. Everybody see too many connections for a model. When expert modelers see something with this level of connection for a system model, they say that's too much, that is impossible to carry out. But on the other hand, that's an expression of how the stakeholders see the relationship with everybody else. So what we applied here was a qualitative simulation model, dynamic simulation, utilizing a very powerful qualitative algorithm, which is called the K-sim. It's a dynamic model. But from that, we used stochastic modeling, Monte Carlo simulation. For each experiment, we carry out for each of the conflicts, we carry out about 1,000 simulations. What would you end up with millions of iterations? And then we utilizing several techniques of data mining. What we look for what you see at your right, that is a technique of this called parallel coordinates that we're aiming to identify the thresholds where changing one forcing variable would cause a detriment in the other one. And for example, this is an actual sample. When you increase urban areas according with the rules of the simulation model, when you increase the urban area in at a rate above 1.8% a year, then you have a change, a probability, an acceptable probability, about 10% of losing or damaging 1/5, 20% of the coastal lagoons. So we have this kind of inferences that, of course, they're a product of the whole process. But then you have a tool for start implementing restrictions with some kind of basis. And this is an example of what I was referring of the worst scenario in this case was for the aquifer. So what we can find in this way are the thresholds of that something undesirable could happen in the future. And the last one is the part of the proposal. So you have your diagnosis, your prognosis, and now you have to analyze everything all together. And for this, we have I want to show a couple of tools. In this case is it's the same technique, parallel coordinates, but now I'm showing the different environmental management units. And what you see at the bottom with the vertical lines, with all those lines that you see there, are the different in the vertical lines. The parallel lines are different environmental indicators. And if you may see, you see that the two of the indicators have been selected. Are the fourth and the third from right to left, and you select that for some purpose that you want to find certain aspect and how distributed territory, and the platform shows this to you. So then the participant can start grasping what is the implication of certain regulation of certain state of the land directly and present whatever is there. Because this is another example. It's just note that this. Oh, sorry. Oh, I don't know what I did. Oh. Know what happened? Here we go. Are you looking at the presentation? Oh.
We don't see it at the moment here.
Yeah, Luis, maybe if you can reshare.
Okay. Let me see. So now, are you looking at it?
No, it's still not showing us.
Well, I picked. Let me try again. Sure. Okay, now. Contents of my camera window. Sorry about that. Here we go.
Oh, here we go. Nice. Oh, there it is.
So this is looking these indicators from looking at from these two indicators the higher values where those indicators would be located, and the same indicators now where that would be located when they have the lower values. So it's just to show how it is can be that it is used, how can answer important questions. This is now another case. I just wanted to show it. We haven't implemented this in the context of ecological ordinance. We still have to carry out some more meetings. But this is how you start getting into agreements on the different positions for getting out to the proposal. So this is an actual case between development and conservation for a project in a coastal area that was between two Ramsar lands. It was a tourist development project. So this is a Fosse pattern recognition model that helps you to identify. So basically what you identify is the degree of impact and the vulnerability of each environmental management unit that you see in white in different areas. So you select the position, from which position you're looking at it. And this is the position of the developer. And of course, after you finish an environmental impact assessment of any sort, the developer will interpret those results that there's no impact. So the green is you don't have impact. But this is an artificial result of using a scale that have equidistant category codes of impact. Typically, you classify your impact from very low to very high. In this case, it's 5 degrees, and it is in color. But from the perspective of a conservationist, the same information would look like this. And you haven't changed anything in the actual data, not in the impact, not in vulnerability, but just under the rules you understand your environment and how you classify the result. And again, you go from very green, no impact, and total impact. And of course, those two positions are extreme. So this invites people, the stakeholders, to present arguments. How do they classify the territory in the same way? Because in this case, for example, the result is that in this exaggeration is that the abandoned agricultural areas are as impacted as the pristine forests in the same territory. On the other hand, the developers are using the opposite. They're saying that no impact in abandoned agricultural areas is the same as no impact in the pristine patches of forest. So when you start modifying all these parameters, just modifying a single parameter, then you start getting other representation from the same problem until you get an idea of the pattern that you come up on conclusion step by step. So I would like to finish just with my question of how does it end. And in my experience, I say it ends well if you find and you justify with sound technical scientific arguments. And in collaboration. When you find collectively patterns, thresholds, tendencies, trade-offs, and risks. That's the building blocks of a good ending. And for me, and I apologize that I couldn't show this tool in actually how it works. It would be a lot more fun for everybody to look at in live, instead of trying to give a description, static description. I would say it ends well with the right decision to support tools. And I would welcome your questions. Thank you.
Thank you very much, Luis, for a very interesting presentation. I would like to open the floor and see if anybody has some questions. I have a few, but I think maybe someone from the audience has specific questions for Luis. maybe if people still think about the question, Luis, I find it quite fascinating. It's amazing what you can bring to all the data you can bring together. But I think what's very interesting is what happens in the room when you sit with the different stakeholders and work with them to go, as you said, to get the patterns, the thresholds, and things like that. And for me, the question is also like, if you think, yes, you want to, is it even feasible to achieve consensus, especially when you have very different interests? And so how do you navigate that? You know, I feel like the modeling is the easier part than sitting with these different stakeholders in one room.
Yeah, well, the way we do it is we follow two. That's more theoretical. But the first step is achieving narrow equilibrium consensus. So we don't bring everybody together simultaneously. We start stakeholder by stakeholder. So we meet first with conservationists, with industrialists, with developers, with governments but that is called narrow equilibrium consensus. What we want to achieve is the sectoral representation of what are their needs without considering anybody else. The major difficulty I found it at that moment, and this technique helped a lot, but it takes between 20 to 30 hours to arrive to a final map that is acceptable of interacting with the stakeholders. You must be aware when you do this, that you touch in very deep beliefs, interests, needs, ambitions, aspirations when you start dealing with this, because at the very end, what you're trying to craft is a prohibition, a regulation to limit somebody's use of the land. So there are actually stakes in this process. So people can be very difficult to deal with, and you have to start working with them with the techniques and just showing that it is not your idea, is your beliefs, your needs, whatever you want of the land, but represented in space in this way. If you say A, B, C, then represented is the green areas are this. So this is a tool to be agnostic. My own position doesn't count. My belief doesn't count. Of course, I have a position. I'm a biologist, I'm a conservationist, and I have to deal with developers. But it's their representation, not mine. So when you arrive to narrow equilibrium consensus, then you bring the other steps, that is extended equilibrium consensus. So you do bring everybody else, and you have now more restrictions, and you have now the modeling aspects on trying to develop all these patterns and thresholds that would explain why you should limit certain activities in certain way, and trying to convince them. And most of the cases, it's again, the mine is very difficult, that is in the best interest of the sector to be limited in certain way. And without these techniques, it would be impossible. At least at the end, I was still alive and talking to everybody else. That's an achievement.
That's great. I see Michelle has her hand raised. So Michelle, do you want to bring in a question?
Thanks. Yes, there's a question in the chat, and I apologize if I get your name wrong. Letitia Piers asks that, Dr. Luis, you spoke about zoning, and they want to know if this is similar to planning units, and what the size of these zones would be. And they've also further asked, is the SIG function and other SIG tools available for countries outside of South Africa? I mean, sorry, outside of Mexico.
I might not leave South Africa after being here for several months. I really like the place, so maybe I should get again. With respect to the use of the platform, I would say that we're finishing what I would call the beta version of the project. It actually works, but it's not ready for distribution. But we would love to come up with some kind of agreement, contribute to in projects, whatever, from our university, and we would love to share the platform, the experience, and it takes a little bit of training to use it. And we're developing actually modules, training modules for using the methods and the platform. So we can be in contact. And yes, of course, it would be great to put it at your disposition. And see if you come out with the same opinion. I like the platform, but
Luis, maybe you can put your contact details into the chat, because I think they weren't part of the presentation. So
yeah,
people want to contact
I'm going to put it there, and I'll try to look for the chat. And now, with the size of the zones, before I distract myself. Actually, what we don't have any restriction of the size of the zone, either the small or the largest. Is whatever comes out from the analysis, and so basically is whatever is the minimum mapping unit in the cartographic sense. So that's part of the resolution of your analysis. Now, and there are when you finish the first part in the zoning, that is great. But then when you have to deliver an actual product for policy making, now it's a lot easier than some years ago. You have to be able to locate the spatial units very precisely, because there are regulations they've got to put in place. So you may adjust your planning units and some attributes of the land by landmarks or highways, whatever is useful to you, and so you may correct some of them when it is practical. You have to be very pragmatic at the very end. But we're not imposing any preconceived view of how these units emerge, like geomorphology or whatever. Now, the tool may use any kind of a spatial arrangement that you may want to use. I don't know if I answered the question.
Yeah, you did. Thank you. Are there any other questions? Please just raise your hand. Okay. Luis, I just had a question in relation to scale. Is there a particular, I don't know, oh, there's another hand, but maybe just in relation to scale, is a particular scale where it works very well? Because I was just thinking, if you, for example, take the agricultural sector, and sometimes you have so different interests, you know, you can have a small scale or subsistence farmer versus a big agribusiness commercial. So you can't even say this is what the sector needs. So I wonder, is there a limitation in that?
That's a very good question. The basic limitation we have in Mexico and most countries I've been around, it's is the availability of map of maps. So you're restricted to basically, for example, in Mexico, to 1 to 250,000 scale. This is the national scale for most of my players. There are some layers at 1 to 50,000. So you may make some zooms in certain areas, but basically, it's, you have that limitation. But the question that is interesting is that in these kinds of analysis, in the way you do a numerical classification, for example, you have a small farming unit, very small farming unit, surrounded by a very large farming unit. So you obscure the interest of the very tiny one, just for because your statistics pulls you away from that. You become blind. But we have developed to deal with that problem with some indices that what you modeling in that way is not the size of the land, whatever, but the interest that a settler could put in a certain parcel of land. For example, you have a very large tract of land. For example, a conservationist, I would build a natural reserve everywhere, no? But that might be a very small farmer, and if that farmer is the only thing he or she have, he will fight a lot more for that tract of land that you will fight for a very large tract of land. So basically, in our analysis, what we depict is that inequality in the fighting, but simulating the size of the conflict, even if it is small or tract of land, the size of the conflict is very large. Yes, but
Okay.
you don't eliminate that through a scale. You eliminate it through an analysis. We have it somewhere there. Yeah.
Yeah, but that sounds really interesting. Leslie, I see your hand is up.
Hi, thank you so much. They're really informative and very helpful. I think that so first of all, one of the things that I really value, I come at this from the point of view of the social sciences, and one of the things that I really value about what you're doing is that your approach allows for different versions of what is of concern in a landscape. And I'm really fascinated by that in terms of coming from Mexico, which is a space of profound contestation, much like South Africa, or in fact this continent as a whole. So the capacity to demonstrate, literally the contest in the ecology is really valuable. One question I have, as we work with communities where there's often a very profound distrust of science, one of the questions that we're thinking a lot about in our environmental social science and humanities program is how to put the tools of science in the hands of people themselves. So, for example, just air quality sensor, using a purple air sensor, which is at least not very affordable, but certainly a lot cheaper than most, and something that a research project can put in the hands of community, and then they can begin to manage the production of data themselves. So in terms of building trust with communities, the question for us then is, what tools can we use that are affordable and that build public science, or public involvement in the production of data? And I was curious as to whether your team that is developing this tool has thought much about that, and has perhaps experimenting with low cost data tools that are accessible to members of the public. Thank you.
Yes, thank you. Well, I made refer to anecdote and an actual experience we had several years ago before we had this tool. Is that we had a meeting in the good old years that we had to do a workshop with fishers in a coastal area of Mexico. And it was very difficult to go there, to have the meeting, to take our laptops, have a meeting in a very intimate way with the fishers, directly with them, with representatives, and we have a great meeting. And but we just developed in those days just the basic multi-criteria model, and then we went back to our university. Of course, by the time you end some work like that, you're tired, and I'm kind of lazy, so I didn't want to do anything when I went back to immediately. So I decided not to check what happened. And I paid that very, very harshly, because then when we open up our platforms, our multi-criteria models, whatever, everything was lost. Everything. So all the information was gone, and it was very bad, because actually the fishers, the poor fishers, gave us their time at their cost for having this information. So again, after we could arrange everything on our side, we have to travel again 1 month later or 2 months later, I don't remember, and ask the favor to work with them again. And of course, they were interested, but they were really mad. They accused us that we were very corrupt, we were representing the enemies of the poor fishers. They thought that we were representing the interests of the tourist developers. They wanted to blah, blah, blah. You can imagine. And they were right. I mean, they were right to be mad. I mean, we were not representing anybody. But the thing is, after we received all the punishment we deserved, they actually accepted to work, and the results were the same. So now I wasn't lazy. I was a good boy, and check everything again after doing that. And then we had to come back and develop the maps, and come back 2 months later and show the maps, and if they agree, and consensus. So that took a lot of time. That's why we developed this technique that in a very relatively it's a lot easier to work with this tool, with this platform, and have the maps directly produced with them, and I would say, instead of several months of coming and going and several meetings, have a workshop of 20 to 30 hours and produce the maps directly with the people. So that saves a lot of cost and time with the user, especially if they're poor. You have to be very conscious of them. And but the interesting thing is that what I try to explain this in some other areas is that it is it puts the disenfranchised of the poor communities, the like fishers, poor farmers, whatever, in a positions to be to negotiate from a position of equal value that the stakeholders that are all powerful, like big industrialists, whatever. Yeah. And the reason I'm saying that is because you're evaluating everything under the same conditions. You're using the same equations, the same framework, and what I say is that the sectors that are rich and powerful, they live in the world of equations.
Right.
And the others do not live in the world of equations. So right. This is a way of bringing them in equal condition with the same equations. Right. And actually, in my experience, both groups understand what's going on better in that way. Right. So again, I think this makes the whole process cheaper, especially for that is not too costly for the people on disadvantaged conditions.
Right.
Great.
Gracias, Franco.
Gracias.
Thank you, Luis. I know we are running out of time almost. And Michelle, you had your hand up, but I also had a final question that I would like to ask Luis. So Michelle, if you want to, yeah.
Yes, thanks. There was a question in the chat. I know we are running out of time, so maybe Louise can quickly touch on it. Letitia again asks, we are currently trying to model offset areas for future land uses, and we need a cost layer. I'm not sure why, but this information is not what people typically share. For example, the cost of purchasing land or cost of restoration. Did you have a cost layer for your modeling processes, and how did you generate this layer? Perhaps combining various social layers as a workaround.
Yes, very briefly. Well, there are several techniques to calculate the cost, or to estimate the cost. But what I would say is that even if you have knowledge that it is relative, for example, certain areas are more extensive than others, and you gather that knowledge, the important thing is that you transform that scale, even if it is qualitative or if it is quantitative, whatever, it doesn't matter, to a scale that is of what is called a value scale. It's a value function, a scale of desirability. Because the cost has to be transformed is if it is more or less desirable for a particular activity. So that transformation, it's used through the value functions, and then it simplifies your task because then you can simulate many value functions until you find the best one that represents the phenomenon you want to model.
Great, thank you. All right, because it's 2 o'clock, one final question from my side. And Luis, this actually goes beyond the presentation, but because you have been working so much in the transdisciplinary space, you know, with the multidisciplinary research groups, with policymakers, with different sectors. And I'm just wondering, based on your own work, how do you think we can prepare students and train them better in transdisciplinarity to kind of deal with all these conflicting perspective and trying to reach a certain level of consensus, but also be quite sensitive to power dynamics and issues of equity? Yeah,
that's tough. I mean, the first thing I would say, you have to carry out transdisciplinary inquiry not because you like it or you enjoy it, only because you need it. It's awful to work in a transdisciplinary world. It's difficult, it's painful, but anyway, and there are different roles. And I would talk from the role of the one that integrates the information. So the important thing that you have to learn for me is how to be agnostic. Your opinion doesn't matter. And actually, you have to separate. You have to be like a Buddhist or following Schopenhauer's philosophy. You separate from the problem. And the philosophy of pessimism works very well in this. Basically, you don't care. You have to be in a position, and that is difficult because, of course, you always have an opinion, and you get into sustainability science because you have a stake in the problem. You want to solve problems. You want to make the world better, and the students want to do that. The challenge is you integrate how you separate yourself from that. And for me, there are certain things that you have to learn: axiomatization and mathematization of the problems. That organizes the information and gives you the best tools for arriving to a decision that if you're working with problems of the real world, your solution is going to satisfy nobody. Nobody will like the end solution. So, but it's the best one if you want to prove it. So it's challenging.
Yeah, no, thanks so much for sharing. And I think that's really important to have this very honest discussion, you know, how difficult it is, and also like having your own positionality. But does it then mean for you that you kind of need this mathematical, like basically you need the modeling as part of the transdisciplinarity, or can you approach it differently too?
That's an important question, but how, my problem is, how do I prove that I have a transdisciplinary result? How do I prove that I have co-production of knowledge? Where to sit the sides? So you may have a narrative, and that might achieve it. That might be. But I think, at least for me, and I'm not good in mathematics. Don't think that I'm good in mathematics. For me, when you go, when you make use to the rules, of axiomatics and mathematization or formalization, let's call it that way, then you can give better explanation of whether you achieve co-production of knowledge or not. And then there are several discussions, but what I would say is that co-production and transdisciplinary results are an emergent property of a process. So you have to show it that it is actually something different that you already have. It's not simply a collection of different viewpoints.
Yeah.
I don't know if I have achieved it or not yet, but
no, you definitely raise a lot of important questions. I think that some of us have to go and think about it quite carefully. But thank you very much for the presentation and all the insights. And thanks everybody for joining us for this seminar. And with this, I think we can close today's ACDI seminar. Goodbye, everybody.
Okay, bye.